Hi again, third grade again. I miss you guys a lot and I can't wait till I get to see you guys again face to face. I just wanted to say hello and welcome you to today's math. Let me get our calendar up here so I can explain to you what lesson we're going to be looking at today. Today we're going to be looking at Tuesday, May 5th, lesson 20.2, Symmetry, pages 410, 411, homework RWPW 106. Okay, some things that I would like you to have ready to go before you start today are, obviously you're going to need a pencil, so make sure you have a pencil. I would also like you to have a clean sheet of paper handy, ready to go. I would also like you to have your math book, and your math book needs to be open to page 410. I will be putting that up here for you to see. I also have my math paper right here so that we can both write on our papers at the same time. And I'm also going to ask you to find your math packet for later on when we do our math homework today, RWPW. Okay, first things first, let me go ahead and get our page ready to go. I'd like you to find page 410 in your math book. And up at the top, it has this interesting word. Let's talk about this word right here. All right, let me get this ready to roll. And before we start, let's get our paper ready. I'm going to go ahead and put my name on there so we know whose it is. And I'm also going to put page, and I believe it's page 110 that we are starting on, 410, sorry. Page 410 that we're going to be starting on today. All right, let's talk about this word. We talked about shapes being congruent the other day, and we said congruent meant the same size and same shape, and then if we moved one shape over the top of the other one, they would match perfectly. We're going to talk about something matching again today, but it's going to be a little bit different than being congruent. This time we're going to talk about this word right here, symmetry. Symmetry, and it's spelled kind of strange. It has two M's in it, symmetry. Now, it says, half and half, a figure has symmetry if it can be folded along the line so that the two parts match exactly. The line is called a line of symmetry. Okay, now, I'm going to go ahead and come down here, and before we start looking at these shapes, I cut out some shapes, and I want you guys to see what I mean about a line of symmetry. Okay, the first shape I'm going to grab is a square. Now, think about it. Is there any way I can fold this square so that it folds completely in half and both sides match? Now, one way I'm going to fold it is this way, and if I make the corners match, let's look at it, and I open it up, both sides match exactly. Now, there's my first one, and I'm going to go ahead and with my marker draw the line of symmetry. There it is right there. If I fold that square in half, both sides match completely. That shape has symmetry. Now, the interesting thing about the square is there's more than one line of symmetry. I can fold it this way, but couldn't I also fold it this way from top to bottom? And both sides match perfectly. I'm going to go ahead and unfold it, and I'm going to go ahead and draw my line of symmetry there. There it is. And the square is actually very unique because there's another way. There's a couple other ways we could fold that and both sides would be the same. I'm curious if you guys see that. What if I take this corner and this corner and fold it that way? If I fold it, do both sides match perfectly? They sure do. So I have another line of symmetry right there. I folded it from there to there. You can see the line of symmetry here. Now, I'm pretty sure that if I can take this corner and they match, I bet I could take this corner and fold it this way and they would also match. Oh, it looks like I'm going to have another line of symmetry there. Yep, both sides match perfectly, so I had another line of symmetry on that square. Okay, so that square has several lines of symmetry, places I could fold it to make it match, both sides match. Okay, there's my square. I'm going to get another shape up here and let's take a look. What about this rectangle? I bet it's pretty similar to a square. They both have 4 right angles. trying to see if there's a place I could fold this so that both sides match. You guys think of a way to do that? I'm wondering if I fold the top to the bottom, if both sides would match. Oh, look at that. We found a line of symmetry right there, so there's one. Okay, can you think of another way I might fold that so both sides would look the same? If you said right down the middle, you are right. Now my class, I would call this folding it the hot dog way. If I folded it the hot dog way, again, I would have another line of symmetry right there. Okay, so that's an interesting shape, that rectangle. Now, I'm going to show you something a little different. Now, this is a little bit different than the square. The square had 4 equal sides, 4 right angles, 4 equal sides, but rectangle doesn't. The rectangle just has the 4 right angles. So I'm going to show you something a little bit different with the rectangle. If I were to take the rectangle and fold the sides or the corners like I did on the square, look what happens. If I fold this one and this one, do they match? Okay, so I'm going to say that if I fold it right here, this rectangle does not have symmetry right there. The only way that we could find symmetry is if I were to take this and cut it. If I cut this shape along the line of symmetry, I could make a congruent shape. Let's see if I can find some scissors real quick. Let's see, I may have to just grab them. Sorry, 3rd grade, let me get caught up. Okay. This line of symmetry did not match, so that's not actually a line of symmetry. But if I were to cut it this way, I would have 2 congruent shapes. So be careful with that. Be careful with that one. That actually is not a line of symmetry. If I folded it from here to here, it wouldn't match. But I could take this shape, rotate it around, and I'd have 2 congruent shapes. If I open it up, that doesn't make a rectangle. So just be wary that the rectangle, if you fold it corner to corner, does not have a line of symmetry there. Okay, next shape that I've got for us to look at is a circle. Now, this one's really unique. Think about a circle. Is there a way I could fold that so that both sides were the same? If I folded it just here, does it match? Not really. If I just folded it up here, doesn't really match either. If I fold it in half though, do I get a line of symmetry? Let me see, make sure I get it really well folded. There we go. Yep, both sides match. They're exactly the same. So there is a line of symmetry in a circle. The unique thing about the circle is I could fold it anywhere in half, and it's going to have a line of symmetry. Folded it there, could scoot it just a little bit, fold it there, scoot it just a little bit, fold it there. If I fold it anywhere in my circle, anywhere, I'm going to have a line of symmetry down the middle, so just keep that in mind. Okay, there's my shapes to start with. Now, I think people hopefully understand and see what the line of symmetry is. The line of symmetry is where a shape, if I fold it, the 2 halves match exactly. Now, something to think about. Some figures have 1 or more lines of symmetry, just like the square, just like the rectangle, just like the circle. Okay, there was one other shape that I forgot to show you guys. I'm going to show you on here. What about a triangle? What about this triangle? What I have here is an isosceles triangle. I notice that this side and this side are equal. I have a right angle and 2 acute angles. Is there a way for me to fold this triangle into a line of symmetry? Now I folded the top down, well, that wouldn't match. What if I folded it this way? Would I have a line of symmetry down the middle? I would. Now it works on this triangle, the isosceles, and it will also work on an equilateral. But what if I have one of these? Here I have a scalene triangle. I have a right angle. Actually but I do believe it's a scalene triangle. This side is not the same length as this side is longer. There really isn't any way for me to fold this to get a line of symmetry. So it just depends on the triangle. You need to look very carefully. This is an isosceles, it'll work, but on the scalene it doesn't work. Okay, so let's go back to the book here. Let's look. Some figures have more lines of symmetry, some shapes don't have any. Like I just showed you, that scalene triangle doesn't have any. Take a look at this interesting little shape. If I folded it right here down the middle, both sides would be exactly the same. Same thing with that rectangle we talked about. We did say that the rectangle folded corner to corner did not have a line of symmetry. Look at this one. We have an equilateral triangle. I could fold it in half there, this way. I could fold it this way. An equilateral triangle has several lines of symmetry, but look at this one. There's no way to fold this guy in half that both sides would be the same, so that one has 0 lines of symmetry. Okay, now down here, I'm going to scroll down the page. They wanted us to copy a rhombus on blue paper, the blue rhombus, and see if it has a line of symmetry. Now you guys don't have one of those at home, so I went ahead and made my own rhombus right here. I'm going to cut it out. And let's see, I bet you guys can already see a couple of places there by looking at the book where we have a line of symmetry. You can tell already I can turn it top to bottom and we'll have a line of symmetry. Let's see. All right. Yep, if I fold it top to bottom, I have a line of symmetry. If I fold it this way, top to bottom, I will also, oops, if I can get it to go, I will also have an interesting line of symmetry. Okay, and there we go. I folded it that way. So I have 2 lines of symmetry on this guy. Let's see. Okay, we had one folding it this way, left to right, and I had one here folding it that way. Okay, so 2 lines of symmetry on that guy. All right, let's continue on here. I'm going to go ahead and go on to our next page, which I believe is page 411. Let's take a look at it and see what we've got to look at here. Okay, starting out, we're going to go ahead and answer some of these questions. Let's take a look at number 1. I'm going to go ahead and get started up here. Number 1. And it says, do you know how the blue line in the figure at the right is a line of symmetry? So let's start with number 1. Now take a look at that. We all know that shape. There's a heart. And if I folded the heart this way, would both sides be the same? Yes, they would. So we have a line of symmetry. So how can we explain that line is a line of symmetry? And when we fold it on the line, both sides are the same. Okay, let's see. I'm going to go even start with that. When folded on the line, okay, when folded on the line, both sides match. And that's key word, both sides match. When I fold that this way, both sides match. They're exactly the same. Okay, let's go ahead and go down to number 2. And it says, tell if the blue line is a line of symmetry. Write yes or no. So let's go ahead and look at number 2. And look carefully at number 2. If I was to fold it right there, would those match? Yes, they would. Okay. Number 2 is yes, we do have a line of symmetry. Okay, I'm going to go on to number 3. And take a look at number 3. I noticed that not all the lines have the same kind of angles. If I was to fold that, it looks like this side probably wouldn't match that other side. So does number 3 have a line of symmetry? No, it does not. Okay. Number 3 was no. Now let's take a look at number 4. What about number 4? If I was to fold it on that line, would there be a line of symmetry? Would those sides match? Yes, they would. Okay, and I'm also going to come down and take a look at number 5 down here. Now be careful. They're going to throw some different shapes at you now. I want you to take a look at where they're showing where we're going to fold those shapes. take a look at number 5. Tell if the blue line is a line of symmetry, right? Yes or no? Now, if I folded that shape on the blue line, would those match? Yes or no? If you said no, you're correct. Okay, let's go to number 6. Number 6, check out where the line is. If I folded this triangle on that line, would both sides match? Yes or no? No, so that is not a line of symmetry. No, it is not. Okay, number 7, let's look at it. I've got a lot of pear-looking shape there. Now, interesting, if I fold this shape on the line, would both sides match perfectly? Yes, they would, so we do have a line of symmetry. Interesting on number 7, though, I notice I can fold it this way, but I couldn't fold it from top to bottom. Wouldn't work. Okay, now, I would like us to take a look at number 8, 9, and 10. Now, I'm going to switch from my board to my Elmo so we can look at these together. So you're going to need your paper and your book. I will meet you in just a second so we can check these out. We're going to be tracing these shapes and then drawing the lines of symmetry. So let's take a look at that real quick. Let me get my book ready and take a look. All right, here we are. Looking at number 8 first. Let's take a look at number 8. I'm going to put my paper there. And I'm going to go ahead and on my paper put number 8. And I'm looking through my paper. I can see the lines there. Here I go. I'm going to draw that shape. And if it isn't perfect, that's fine. I'm going to try my best. Okay, that looks pretty close. Now, let's think about that. Is there a way I could take this shape and fold it so that both sides match? Okay, what do you guys think? Okay. Go ahead and grab my marker here. I think, could I fold it right here in the middle? If I folded it in the middle, both sides would match. And I'm also thinking I could fold it this way and both sides would match. I'm not sure about from corner to corner. I don't think those would work, but I do think if I folded this shape in half this way and in half this way, both sides would match for number 8. Okay, let's take a look at number 9. Number 9, we have this T shape. Let's see here. Let me get my paper ready for number 9. I'm going to trace that T shape on my paper. And I kind of go slow so that it looks pretty close. Okay. I'm going kind of slow. This is hard. It's not going to be completely the same as the one in your book, but it's pretty close. Now be careful here. How could I fold this thing to show a line of symmetry where they match? I don't think folding it top to bottom is going to work, but could I fold it this way from side to side? I think if I folded it from side to side, I'd have a line of symmetry. Okay, so there, I think this one only has one. Right down the middle is going to be the only place I could do that. All right, let's take a look at number 10. Number 10. I'm going to go ahead and trace number 10 through my paper here. Let's see, I'm going to go kind of slow. All right. Let's take a look at that shape and see what we think. Okay, I'm looking at this. I don't think if I fold it this way it's going to work, but what if I folded it from top to bottom? Would that match? You have a line of symmetry there. I think if I went from top to bottom, I will have a line of symmetry. I think this is going to be the only one there is, right down here down the middle, from top to bottom. Okay, that's a horrible line, sorry guys. Let's see. I try that again. I'm going to do this real quick and show you a better line. I think that if I folded this guy right down the middle, it would be the best line of symmetry for that one for number 10. Okay, that was number 10. Now, let's go ahead and take a look at number 11. We're just going to try number 11, then we're going to start talking about the homework. It says Jody says a circle has too many lines of symmetry to count. Do you agree or disagree? Explain. Okay, let me get out of this and let's talk about that. All right, and we're on page 411. Grab my marker and let's talk about number 11. Okay, number 11. Again. Ooh. Jody says that a circle has too many lines of symmetry to count. Do you agree or disagree? Explain. Let me find my question in here. Underline my question. Do you agree or disagree? Explain. Too many lines to count on the circle. Do you guys remember talking about the circle when we were looking at the lines of symmetry? How many different ways we said we could fold this thing? Anytime I folded it in half, I would have a line of symmetry. So, do you agree with her? There's too many lines? I think I do, and the reason being is no matter where you fold it in half, there's going to be a line of symmetry. So there could be hundreds, thousands of ways to do that. Okay, so for number 11, do you agree or disagree? I agree. Okay, I agree. And let's think, explain. And we said that you can fold a circle anywhere, and this is important, anywhere in the middle. Because if you don't fold it in the middle, you're not going to have a line of symmetry. I kind of showed you that when we started. You can fold a circle anywhere in the middle, and sides match. Okay, so I agree. You can fold a circle anywhere in the middle, and the sides match. And I remember when we started, I folded it here, which is not in the middle, and the sides don't match. I folded it here, it wasn't in the middle, and the sides didn't match. But on a circle, you can fold it anywhere in the middle, and you're going to have a line of symmetry. Okay, so very good for number 11. Now, I would like to go and take a look at our homework today. So I'm going to go ahead and scoot this off to the side, and we're going to start by looking at RW 106. Let's take a look at that to begin with. Okay, now, I'm going to have you guys work on this with me since you may or may not have a piece of paper at home. Okay, let's see. This is, you can try this if you like at home. You could, if you have a piece of paper and scissors. It's asking you to follow the steps to make figures that have a line of symmetry. If you would like to do that, you could have a clean sheet of paper, and on the fold on your clean sheet of paper, let me grab a paper. If you would like to try it, you sure can. You can take your piece of paper at home and fold it in half, and then where the fold is, they said, where the fold is, the folded edge should be one edge of your figure. So I'm going to put it up here, and I'm going to draw a figure on there. Let's see, kind of like what they had. Okay, and if you want to try it at home, you can cut it out. I'm going to cut it out along the fold. I'm not going to cut through the fold, but I'm going to cut the lines on the fold, off the fold there. And I'm not going to cut through the top folded part, but there's that. And when I open it up, I have a line of symmetry where the fold was. If you would like to try some of these at home, you may. It says to draw a figure, cut out the figure you drew. Do not cut the folded edge, so cut out around it. And then open up the figure you cut. The new figure is symmetrical, and the fold is a line of symmetry. If you would like to try that, you may. Now, what I am interested in is the back of our paper today for our homework. Okay, and here's PW 106. Let's take a look at the back. Should be in your packet. Let's take a look at our page today. Now, it says to draw the lines of symmetry. Now, before I get started, I'm going to put my name on there. So, what belongs to, let's see. And let's look. I'm going to help you with a few. Okay, take a good look at this. Draw the lines of lines of symmetry. So there could be more than one. Take a look at that letter A. Is there a way to divide that in half so both sides are the same? If I went this way, I know that wouldn't match, but what if I went from top to bottom? Would that be a line of symmetry? I think it would. I'm going to let you try 2 and 3 on your own, and be very careful, guys. Little hint. There's more than one line in both of those, so look carefully. Now, for 4, 5, 6, 7, 8, 9, they want to know, is the dashed line a line of symmetry? Tell if the dashed line is a line of symmetry, write yes or no. Here's that circle. Remember what we said about having it to be in half? If I folded it right there, would it be a line of symmetry, yes or no? If you said no, you are correct. I think you guys can try 5, 6, 7, 8, and 9 on your own. Be careful. Be careful with number 6. And the last one, you've got a couple of questions down here. Okay. Be careful with these because they could be adding or subtracting or multiplying or dividing. So be very careful with both of those down below. Okay. Thank you for joining me today. If you guys have any questions, be sure to let your teachers know. And again, I am hoping to see you guys really soon. Let me know if you need some help. Thanks and have a good day.